Thank you, Wim. So as Wim introduced, I am a researcher, so I'm making research in VTT, Technical Research Center of Finland, especially in the field of eco-efficiency and assessment of different land use and urban development solutions. My title is Understanding Ecosystems, Enabling an Eco-Efficient Urban Future, with the question mark. You will find out later why the question mark is there. So, first of all, we have to agree about the basic key concepts. First of all, the ecosystem. I would define it like this. It's any group of living and non-living things interacting with each other. It can be local or global. So it's very, very large concept and very popular nowadays. Cities and other urban communities belong to the ecosystems as well. So they are man-made constructions, but there are also social network involved. And you can look at the urban ecosystems from two different angles. You can define the urban ecosystem as ecosystems in cities. This is more a conventional way to look at it. So all the natural elements like air, water, soil, flora, fauna, ecosystem services, biodiversity, carbon cycles, they are all included in that approach. And the second way to look at it is the ecosystems of cities. That means that all the cities and all the complexities included in the urban network globally are involved in this aspect. And the second important concept is the eco-efficiency, which is getting more and more popular when you are assessing different solutions in land use planning and in urban development as well. Verbally, you can define it as a quality of life at the cost of resource consumption and environmental harms. And of course, the climate change and carbon cycles are included in these issues. But to make it sure that we understand it in the same way, I'm emphasizing that the awareness and understanding of these key concepts are essential when enabling and promoting eco-efficient urban future. Well, you can make a mathematical formula, or at least a formula that looks like mathematical for eco-efficiency. It looks like this. It is originally made by World Business Council for Sustainable Development already 20 years ago, but it's also adapted by OECD, so it seems to be quite common definition. But you can look at it also from two different angles. You can take it quite broadly, which means that you include many different type of indicators. Much of them are very intangible. Or you can look at it in a very concentrated way to focus on the hardcore indicators only, like, for instance, carbon footprint, which seems to be the most important single indicator. So if we choose option A, we need practical tools to combine different aspects, and if we choose B, then we are going to have a more simple task, just to minimize atmospheric CO2 equivalents. And for that purpose, if we take the option A, we have some tools in the market, or let's say not always in the market, but at least on the desktop of different developers, but they cover the spectrum in a very different way. So we made a short excursion to these tools and took 40 of them and made this kind of analysis. And the table presented here is the summary only of this analysis. On the left-hand side, you can see the names of the tools or methods and the name of the developer as well. And on the upper part, you can see the elements and indicators included in the assessment tool or methods. So there are more or less at least around 40 different aspects which are taken into account in the tools. And in this comparison, in the summary of the comparison, we just wanted to make a big picture. What of the elements and indicators are included in the tools which are available and which are not excluded. The included ones are with the blue color, either dark blue or light blue, and those which are not included are in the red color with the minus marks. So I won't go into detail, but the general conclusion is that there's a big variation in the scope and coverage of the tools and methods. The rest of the 40 tools are in the second part of this table. These are the results of the so-called KECO study, which we are now going to finish in a few months. Then I take another example, only one example of the tools which are available in Finland. This is so-called HECO tool, which is developed for the city of Helsinki, enabling the city planners to assess the city plans in a quite simple way. It's a matrix where different aspects of and issues in the land use planning process are included here, altogether 21 issues, and they are all assessed from the 6 viewpoints of eco-efficiency mentioned here: materials, energy, renewables, emissions, waste and recycling, and ecosystem at last. You can define quite transparently the weights of each of these criteria, assessment criteria, and after this you can get variation of points which are available for the solution you want to assess. And this is the table and pie chart describing the relative importance of different sectors which are going to be assessed by this tool. So as you can see, the issues dealing with land, for instance, the land use efficiency and building densities are included here, and the energy questions are, of course, very, very important, and as well transport and services sectors. Anyway, this forms the total picture of the so-called eco-efficiency, which is assessed by this tool. And as a result, you can get different types of results. So the total points in numbers, for instance, the normal level is 100 points, and then you can get the spider net graph, including all the 21 indicators, and you can get the color and letter code as well. And finally, okay, this is also a more detailed picture of the spider net graph. And finally, you can get this kind of the most simple graphics of the eco-efficiency. So in real time, it shows where the level of eco-efficiency in your case is going to be after your own assessment. So during the development phase, we made some test cases, and these are some pictures of the tests. One area was called Meritastila in Helsinki. These are the 3 original plans. So 2 years ago, and in the second phase, there was new alternatives, option 1 and option 2. As you can see, there was difference. The development was made after the assessment, and there was also some other aspects which are involved in the development, not only the use of the eco-efficiency tool. Well, anyway, in this case, the study results seemed like this. The total points were 102. Sorry of the Finnish language here, but you can see the general idea. And as a verbal definition, it belongs to the class good. And the other cases are seen here. 2 of them are in Helsinki, and the last one is in Tampere. And to take another example from the Helsinki cases, this circumulatory land use plan or town plan developed during the process something like this, and you can see the difference very clearly between those two plans. And of course, you can also make the calculation on a regional level. This is the region around Helsinki metropolitan area, showing the Helsinki area here and some other smaller cities around it. The scale of the map is around 100 kilometers square. And in this case, the eco-efficiency indicator is the energy consumption. So between different alternatives, you can very clearly see the difference if you change the picture from one alternative to another. So it's clearly visible how the different scenarios differ in the aspect of energy consumption. And the same thing with the CO2 emissions coming from the construction phase, the operation phase, and the traffic transportation in the area. So this is a life cycle approach. All the CO2 emissions are counted together and calculated in each square, which is 1 kilometer by 1 kilometer. So you can also see the difference between different scenarios very easily. So these are the tools we have been developing for land use planners and also other urban developers. Well, going back to the original formula, if you take option B, if you want to concentrate only to the carbon footprint area, so it's more easier to make so-called mathematical calculation. If you take the urban ecosystem as a whole and count all the carbon which are on the input side of the system, and also calculate all the carbon which is on the output side of the ecosystem, you can easily, well, I wouldn't say easily, but anyway, in theory, it's easy to understand. The comparison is much more easier. So if the A is bigger than B, then the urban environment will consume more CO2 equivalents than it creates. That means that the net effect will be the decreasing CO2 equivalent level in the atmosphere. That seems to be the direction we want to go. And the carbon cycle is really one of the most important single indicators in this eco-efficiency assessment procedures. And as we all know, the carbon cycle is disturbed and measured by the atmospheric carbon days. For instance, in the Mauna Loa, Hawaii, where the longest time series started by Professor Keeling. So this is called the Keeling Curve. And if you look at the latest development, you can easily see also that there is no progress so there seems to be no slowdown of the development. As a matter of fact, it's on the contrary, the change seems to be accelerating. The ppm level per year, the increase is increasing. So that is one very disturbing fact you have to face. So if we consider Earth's climate as its own ecosystem and think in the parallel to the human ecosystem, and especially the energy production, which can be seen in this satellite picture of the light emissions through to the atmosphere, it can be clearly visualized. My question is, are we actually aware of causal relationships between those two systems, the human ecosystem and the climate ecosystem? So much we know that the total global balance of CO2 emissions or CO2 equivalent emissions have been calculated, and if we take those parts separately, which are related to built environment, we can clearly see that the important role built environment has in the global greenhouse gas emission balance. So this is the play arena, climate ecosystem and urban ecosystem affecting each other. So they, as you could see, there's a strong link from urban ecosystem to climate ecosystem, but what is weak is the feedback link from climate ecosystem to urban ecosystem. There seems to be no response from the facts which are happening in the climate ecosystem due to the decisions made in urban ecosystem. So the feedback is, but is it working or not? That's the question, and I would say it's not working properly. Why? Because the efficiency of urban development is not acknowledged, it's misunderstood or neglected for some reason. We can speculate.
This one is close now.
Okay, as you know, the urban world is urbanizing very rapidly. So we are now in phase where around 53% of the people are living in urban areas. In North America, it's 83%, and Europe is 73% at the moment. So the focus area should be in this part of the graph. And to be more exact, the new urban development will take place in the developing world. This made from the UN prospect data, where the emphasis and the focus has been in the northwest corner of the graph, and now it's turning to the southeast corner. And from the UN statistics, you can calculate that 86.4% of all new urban growth after this until 2050 will be in Asia and Africa. That helps us to see where the focus must be. So at the end of this presentation, I will just make a short excursion to the classic literature of urban development, maybe also architecture, starting from Vitruvius, Ebenezer Howell, Le Corbusier, Kevin Lynch, and Peter Hall, for instance. There are a lot of other names as well, but the traditional way to look at the nature, the relationship between man and nature is so that the nature is the bottomless reservoir of material and energy resources, and as well a source of health, mental delight, and refreshment. So far so good, but that's not maybe enough. The modern, let's say, new knowledge is trying to emphasize the complexity, where all the parts, biotic and abiotic, are linked together, and to emphasize the ecosystem where human beings are one part. And to get a more clear picture about what we know at the moment, we made a short study about 40 books, very recent books on urban ecology or urban eco-efficiency. And we found out that, of course, the new themes are very popular, but also that the studies deal more or less with highly industrialized countries like Europe, North America, etc., and very few are dealing with developing countries. There are, but they are very few. And finally, it seems that there's a large consensus that sprawling large cities waste resources, spoil the environment, and create socially unfavorable living environments. And many of the authors seem to promote a kind of return to the compact and walkable city model. But what is missing is the hard fact investigation on the trends of world urbanization and its possible or even probable conflicts with the ecosystem of the whole global urban complexity. So, global tool is needed. That's one of the main points. Here are the list of the books we went through. It's tough for you because you can check them later if you want. And for the last picture, I wanted to show that there are some progress. I took some photos of the nearby environment in Helsinki, where the Ecovik area has been implementing new technologies and new ways to plan urban areas to improve the eco-efficiency. So there are many different experiments in this area. So if you want to see them, it's very easy if you get to Helsinki. They are very close to the city center, this area. Thank you.